All right, let's get started. So today I'm just going to be filming a video on solving rational expressions. So this is the last lesson of this unit. So we've already covered adding and subtracting rational expressions and multiplying and dividing rational expressions. Now we're going to shift our focus to solving rational expressions. Okay, so the difference with these ones is that we have an equal sign between usually two rational expressions, and we want to find the x value that makes this whole thing true, that makes those two things equal. So that's a quick summary of what solving rational expressions means and what we're going to be doing. The first thing before I can even find or start solving for x, we need to find our least common denominator first. So the first thing that I'm going to do in order to find my least common denominator, I'm going to factor a 2 out from the denominator on the right side. So if I factor out a 2, I'm left with x minus 5. Okay, so if you notice, it's pretty close to what we have on the left side in the denominator. The only thing that we're missing is a 2 on the left side. So to get the least common denominator, well, first of all, it's 2 times x minus 5. To get it on the left side, to get the denominator as 2 times x minus 5, we need to multiply this whole thing by 2 over 2. Okay, I'm going to distribute this 2 to both of those, to 3x and 7. So if I do that, I'm left with 6x plus 14 over 2 times x minus 5 on the left side. On the right side, I'm just going to leave it as is since it's already the common denominator. So 2 times x minus 5. Okay, so that got us one step closer to solving for x. The only thing now, we don't like having to deal with the fractions. I know nobody likes fractions, so we're going to take care of that by multiplying by the least common denominator on both sides of my equal sign. Whoops. So we're going to multiply this left side by 2 times x minus 5 over over just 1, sorry. And we're going to multiply the right side by 2 times x minus 5 over 1 as well. So what that will do for me is it will cancel out the denominator on both sides of my equal sign. If I multiply by the denominator, it's going to cancel it out. So on the left side, all I'm left with is the numerator, 6x plus 14. And on the right side, same thing. All I'm left with is the numerator, 5x plus 17. Okay. So at this point, now we don't have the fraction business happening, and we're just dealing with what I have here. And that's the only thing that I have to solve. The fraction thing is taken care of, and we just have to solve for x. And hopefully you've seen things like this. You've seen things like this for a couple years now. It's just a two-step equation to find x. So we're going to get all the x's on one side, all the constants on the other side. To do so, I'm going to subtract 5x from both sides. So that's going to get rid of the 5x there. And I want to move that 14 over as well. So I'm going to subtract 14 from both sides. Get rid of it on the right side. And then let's simplify. So I have on the left side of my equal sign, I'll have 6x minus 5x, which will give me just an x. And on the right side, I have 17 minus 14, which will just give me a 3. Okay, so now I'm just left with x equals 3, and that is, in fact, our answer. Okay, so not too complicated. We're just solving for x, and we have to find the least common denominator to do so. But once we find that, everything else is pretty simple. We're just solving for x. Okay, so that's the first example. Let's go on to the second example. So this time we have a rational expression plus a rational expression equal to another rational expression. Okay, so this one looks a little scarier, but I promise it's not too bad. Again, the first thing that I want to find though is the least common denominator. So the first thing that I'm going to do is factor this middle thing. Anytime that you have a denominator that can be factored, I would always try to do that first. Okay, so when we're factoring a quadratic function, remember quadratic function is something that has this x squared in it. Okay, I want to find two numbers that are going to multiply to be positive 10 and add to be negative 7. So that it just so happens that negative 5 and negative 5 and negative 2 is going to do that for us. So we'll have x minus 5 and x minus 2. Okay, if you notice, the x minus 5 is also present here in the denominator, and the x minus 2 is also here in the denominator. So the only thing that we would have to do to this thing on the far left and this thing on the far right is multiply it by the opposite thing. So our least common denominator is going to be x minus 5 times x minus 2. Okay, so since this middle expression, this middle rational function that I have it already has the least common denominator, I'm not going to do anything to that. The only thing that I'm going to do is to the things that I have on the far left and on the right side of my equal sign. So we need to multiply this whole thing by x minus 5 over x minus 5. So we have our common denominator there. And then the thing that we need to multiply this side by is x minus 2 over x minus 2. Okay, so let's multiply all of that stuff out and rewrite it. So the thing that I have on the left, x minus 5 times 1 is just going to give me x minus 5 on the top. On the denominator, I don't want to multiply it all out again. I'm just going to leave it in factored form. So I'm going to leave it x minus 5 and x minus 2. Okay, and then like I said, we're going to leave that middle thing alone because it already has the least common denominator. So we're just going to write it as 1 over x minus 5 times x minus 2. And I want to leave the denominator in factored form again with that one as well, just to keep it the same and keep it uniform. Okay, so now let's do the right side of the equal sign. I'm going to take this 3 and distribute it to the x and the minus 2. So I'll have 3x minus 6 on top. On the bottom, we'll have x minus 5 times x minus 2. Okay, so now we have our least common denominator throughout all three of our rational expressions. Again, the next thing that I want to do is get rid of that denominator. So I'm going to multiply everything by the denominator itself. So I'm going to make this a little smaller so I can fit everything. We're going to take all of this, I don't want those, and multiply everything by x minus 5 times x minus 2 over 1 times x minus 5 times x minus 2. Sorry if it's getting squished. X minus 5 times x minus 2. Okay, again, if I do that, it's going to cancel all of the denominators out with what I multiplied by. So the only thing that I'll have left are the numerators that I had. So we'll have x minus 5 from that first rational function, plus 1 from that middle rational function, and then 3x minus 6 from the rational function on the right side of my equal sign. Okay, again, we're just solving a simple equation now, and we just want to get all the x's on one side and all the constants on the other side. So I'm going to subtract x on both sides. So we can move that. It's going to cancel out on that side. And I'm going to add 6 to both sides as well. And it's going to cancel it out on the right side. So on the left side, I have -5 plus 1 plus 6. And that is going to give me just +2. -5 plus 1 will give me -4, plus 6 will give me +2. On the right side, I have 3x minus x will give me 2x. Okay, again, we're just solving for x. All I need to do is divide both sides by 2. That'll cancel the 2 out on the right side of my equal sign. So on the right side, I'm just left with x. On the left side, I'll have 2 over 2, which is the same thing. You can write that as 1. So that is our answer for example 2. X equals 1. Okay, so for our third example, I'm going to scooch this over a little bit. This time we're back to having just a rational expression equal to a rational expression. Again, we want to first always find our least common denominator. In this case, it's just going to be x plus 3 times x plus 6. So, excuse me, sorry. So to get our least common denominator, on the left side of my equal sign, I have to multiply everything by x plus 6 over x plus 6. And I'm actually going to switch these around. I'm going to move this over a little bit, just so we can see the distribution a little bit nicer. And on this right side of the equal sign, we're going to multiply everything by x plus 3 over x plus 3. So we can get our least common denominator over there as well. Okay, so I'm going to simplify everything. Again, I'm going to multiply everything out in the numerator. So I'll have 8. I'm going to distribute into the x plus 6. And that'll give us 8x plus 48 on the left side over x plus 3 times x plus 6 on the left. And then on the right side, I have x plus 1 times the x plus 3. I'm going to multiply this all out. We'll distribute the x to both things and then distribute the 1 to both. So we have x times x will give me x squared. Let me do those arrows again. So we're going to multiply x times x will give me x squared. X times 3 will give me 3x. 1 times x will give me just an x. And 1 times 3 will give me +3. And I'm going to leave the the denominator in factored form. X plus 6 times x plus 3. Okay, so again, we want to get rid of the fraction stuff that's happening so we don't have to worry about that. So I need to multiply everything by the denominator, by our least common denominator. So we're going to multiply this side by x plus 3 times x plus 6. Same thing with this side. X plus 3 and x plus 6. That's going to be super squished. Let me try that again. X plus 3, x plus 6. Well, that wasn't much better. Okay, anyway, so when we do that, it's going to cancel those things out, cancel out our denominators. Okay, and all we're left with on the left is 8x plus 48. And on the right side, we're just left with x squared. I'm going to combine this 3x, come on, the 3x and the x, and that's going to give me 4x. And we'll have the plus 3 at the end. Okay, so this time we have a quadratic expression, which just means that we have this x squared happening. Okay, so when I have an x squared, I'll want to get everything on one side and have 0 on the other side of my equal sign. So I'm going to subtract 8 from both sides, and that'll cancel out on the left. I'm also going to subtract 48, excuse me, from both sides as well. So on the left, I just have 0. And on the right side, I'll have x squared. And then positive 4x minus 8x will give me negative 4x. And then that positive 3 minus 48 will give me negative 45. Okay, so when we have a quadratic function, we will want to factor it. So again, we want to, just like we factored on the last example, we factored this denominator to get x minus 5 times x minus 2 here. Oh, sorry. We're going to do the same thing here to solve for x. So we have 0 equals, and again, we want to think of two numbers that are going to multiply to be negative 45 and add to be negative 4. In this case, that's going to be negative 9 and positive 5. So we'll have x minus 9 and x plus 5. Negative 9 plus 5 will give me negative 4, but negative 9 times 5 will give me negative 45. So I have these two factors being multiplied together and equal to 0. I can set each of them individually equal to 0. So we have x minus 9 equals 0 and x plus 5 equals 0. So in this case, I'll have two possibilities for the x value, or two possible answers. So if I solve for x here, I'm just going to add 9 to both sides. So I'll have x equals 9 as one answer. And then same thing on the other side, we'll just want to subtract 5 from both sides to solve for x. And we'll get x equals negative 5. So in this case, we'll have two answers. We have x equals 9 as one possibility. We have x equals negative 5 as another possibility, or our second answer. Okay, let's go on to our last example. Okay, so for example 4, again, the first thing that I want to do every time is find our least common denominator. In this case, this one's not too bad. These two already have a common denominator, but we need to consider this 2 as a denominator in the middle as well. So our least common denominator here is going to be 2 times x minus 7. So we need to multiply this left thing by, oops, I'm going to do it on this side, 2 over 2. Okay, and same thing over here, we'll need to multiply that by 2 over 2. But in the middle, we'll multiply that by x minus 7 over x minus 7. Sorry, again, it's getting squished. I don't have very much room to write on this iPad. Okay, so on the left side, we're going to distribute that 2 to both the 2x and the negative 9. So we'll have 4x minus 18. On the top, on the bottom, I'm just going to leave it factored as 2 times x minus 7. Okay, I'm going to redraw that line. Okay, in the middle, I'm going to distribute this x to both the x and the minus 7 on the inside of the parentheses. So on the top, I'll have x squared minus 7x. Then on the bottom, again, I'm going to leave it factored. We have 2 times x minus 7 for the middle thing. Now on the right side of my equal sign, I have this 2 times 5 will give me 10 on the top. And then I'll have 2 times x minus 7 in the denominator. Okay. Again, once I have a common denominator with everything, we'll want to multiply everything by the denominator. Again, because it's going to cancel and we won't have to worry about denominators and we won't have to worry about fractions, and it just makes our lives a little easier. So we can cancel all of those out. And we're just left with the numerators. So I'll have 4x minus 18 plus x squared minus 7x equal to 10. And again, because of this x squared, we will end up having a quadratic. Again, I want to get everything on one side of the equal sign and have 0 on the other. So I'm going to first combine the like terms on the left side and put it into standard form. So we have x squared first, and then we'll have 4x minus 7x will give me negative 3x. And then that negative 18 is just by itself as well. We have that all equals to 10. Again, I'm trying to get 0 on one side, so I'm going to subtract 10 from both sides to get rid of it on the right. And I'm left with x squared minus 3x, and we'll have negative 18 minus 10 will give me negative 28 equal to 0. Okay, and just like we did on this last problem, in this step, we'll want to factor the quadratic equation that we have. So we want two numbers that are going to multiply to be negative 28 and add to be negative 3. In this case, that is going to be negative 7 and positive 4. So we'll have x minus 7 and x plus 4 equals 0. We can set each of these equal to 0 on their own. So we'll have x minus 7 equals 0 and x plus 4 equals 0. And we can add 7 to this side to get x by itself. We'll have x equals 7 there. And with the x plus 4, we'll just subtract 4 from both sides to get x by itself. And we're left with x equals a negative 4. So again, just like the last one, we'll have two possibilities for our answer for number 4, x equals 7 and x equals negative 4. And that pretty much sums up everything that you'll see and have to do on Canvas with solving rational equations. And that's it.